Alrighty, let's take a look at question number 4. Question number 4, we're going to be assessed on how to integrate composite functions. Okay, so question 4 reads, was the integral of 2x to the third plus 3 over the quantity x to the fourth plus 6x minus 8 squared with respect to x. To get us started, let's go ahead and write down the formula for our problem solving process. Don't forget, we have all the must-know formulas at mathgotserved.com to check it out and download it and make sure you have it all mastered. Alrighty, so the formula we're going to be using here is known as the chain rule form. I'm sorry, not the chain rule formula. Let me not specify what it is. It's the reversal of that. Okay, so if you have wrapper, which integration technique here are you going to use? Ladies and gentlemen, we're going to be using the U-substitution. Okay, it's called the U-sub. It's related to the chain rule. Actually, it's like undoing the chain rule, kind of, sort of. All right, so what's the U-substitution formula? If you're integrating a situation where you have a composite function, let's call it f of g of x times the derivative, or the derivative of the inner function. This can be rewritten as the integral of f of u du. Okay, this happens where we have the inner function assigned the value u. Okay, so remember, u substitution doesn't execute the entire integration process. It's just a tool to condense the integration problem into something that's more manageable, something that's more elegant and easier to integrate. Then after you integrate, you don't forget to resub your value back for u. Okay, all right, so let's go ahead and get started here. So we're integrating this guy right here, so let's write it in this format. I'm going to write it as 1 over x to the fourth plus 6x minus 8 times 2x to the third plus 3 dx. Now, how do you know to use the u substitution? Well, if you take a look at the inner function of the composite and you differentiate it, and you end up with a multiple of the other function, guess what, ladies and gentlemen? That is a u substitution problem. Okay? All right, so in this particular case, check this out. We're going to call our u this inner function right here. Okay? So u is going to be, let's put it over here, u is going to be x to the fourth plus 6x minus 8. Now if I differentiate this and end up with a multiple of this function here, I know for a certainty that u substitution is the way to go. All right, so differentiate both sides. The u is du dx, but I'll put the x on the right side. Okay, so differentiate this. This is 4x to the third plus 6 du dx. You put the dx over here. It's faster that way. That's not a perfect match. But wait a minute, what if I factor out a 2 from here? What do you notice if I factor a 2 from here? I'm going to have du is equal to 2 times 2x to the third plus 3 dx. Jackpot. You see, I got du is twice this. Okay, so whenever I differentiate and you end up with a multiple of the derivative of the inner, a rational number multiple, then you know that you can integrate using u substitution. Okay, all right, so now we know what u is. We know that we're going to be using u sub. 2x to the third plus 3 dx is du, but I have this is a second function. So what is du exactly? 2x to the third dx. I have 2x to the third dx, but wait, we have a 2 here. That's a problem. How do we fix this problem? I want this exactly. My substitution must be clean. That's critical. Okay, I need to have 2x to the third dx with no extras. This is an extra right here. So how do we fix that? What you do is you divide both sides by 2. Okay, so you divide by 2, and you have your perfect clean substitution. You know that du over 2 is going to replace the derivative of the inner function. Twice the derivative of the inner function. Okay. All right, so you have that right there. Okay, so this piece right here, we're going to replace it with du over 2. Now we can rewrite it. It's going to substitution. We're going to have the integral of 1 over u squared. And then this entire piece right here is du over 2. Okay, so let's get this 2 out of the way. We're going to factor it out using the constant multiple rule. So we have a nice looking integral. 1 over u squared du. Now, how do you integrate 1 over u squared? Is there any formula for that? Well, there isn't. So what are we going to do? We're going to rewrite, okay? Rewrite this. So if we rewrite this, it's going to be 1 over 2 times the integral of, using the reciprocal property of exponents, u to the negative 2 du. Now, guess what? We can apply the power rule. Okay, we went over the power rule in question number 1. So let's go ahead and do that. If we apply the power rule, this integral is going to become 1 over 2 times u to the power plus 1 divided by power plus 1. Since it's an indefinite integral, don't forget plus c. This becomes 1 over 2 times u to the negative 1 over negative 1. When we simplify that, we're going to end up with negative, 1 over 2 u plus c. Okay, all right. Are we done yet? No, we need to resub. Okay, what's u? U is x to the 4th plus 6x minus 8. So we're gonna plug that in here. So this becomes, I'm gonna structure it exactly as the options are in the alternatives. So we're gonna write it like this. This is gonna become negative 1 over 2 times 1 over u, which is, what is u? X to the 4th plus 6x minus 8 plus c. Okay, if you wrote it like this, 1 over 2 times x to the 4th plus 6x minus 8 plus c, that's correct. But in this particular option, they just separated the coefficient as a multiple of the rational expression. Alrighty, so we can clearly see that our answer is option letter C. Time to watch this presentation. If you found the contents of this tutorial helpful in your preparation for your exams or calculus in general, do give us a like. Your positive feedback is very, very helpful to us. Do not forget to subscribe to our channel for updates to other presentations such as this. As indicated earlier, if you have any questions or comments, just post it in the comment section below. If you'd like to gain access to our epic formula sheet and other valuable resources to help you do well on the AP exam, do visit our website at mathgotserved.com. Thanks again for watching and have a wonderful day. Goodbye.